Hi, in my last video I spoke about the importance of expanding your horizons and how this can add an overall sense of contentment, calmness, fulfillment, and help you see life from a new perspective. There are many different ways to expand your horizons, but most of them involve either learning something new or exposing yourself to new ideas. And in this video I'm going to cover one of the most powerful and game-changing ways of expanding your horizons, and that is learning to code. So if you're not already sold on the idea of coding, I'm going to cover 4 fundamental and powerful reasons why you should learn to code. So number 1 is it's arguably the most powerful form of leverage. Now leverage is anything that gives you more results with less effort or input. So for example, let's rewind back to the olden times and let's say your job back then was to chop down trees, gather wood for both fire and for furniture. So typically the amount of reward or the amount of output you get is directly proportional to the amount of effort you put in. So for example, if you put 6 hours of work in, you typically get 6 hours of firewood. So if you want to earn a lot more money, you have to work many more hours. Whereas coding in modern times is very different. You put in a certain number of hours or a certain amount of work initially, and that output continues far beyond when you finish that task. So you could create an app or a website or any number of things. And once you've created it once, it's easy to package that and kind of sell that to a huge number of people without any additional work. And even then, once the work is done, it continues to generate money or fulfills the purpose that you've created that program to do. This effectively allows you to work autonomously. So once you've created the product then can manage itself. And that allows you to effectively coast on a beach with your sun loungers and your cocktails, and at the same time you're actually earning quite a lot of money, particularly if that product becomes very successful. In the past this was never the case. If you were a farmer or a factory worker, or even going back further, if you were a hunter-gatherer, if you did not do your job or you didn't do your tasks, you effectively don't get food on the table. So you're very much reliant on your physical labor that you put in order to get what you need out of it. So the second reason is coding is both a creative and a logical process. So most tasks in life are usually one or the other. So for example, if you're a painter, you're typically tapping into your creative juices, and it pretty much relies solely on creativity. You know, you take something, you express yourself, and the end result is kind of almost proportional to your creative ability. Meanwhile, if you were a mathematician, for example, it's typically a very logical or deductive process. So you start with a set of equations and you try to move from point A to point B, where each thing in between is like a logical point that leads you on to the next until you get to the final result. So coding allows you to do both, or one or the other, depending on your particular area. So there's opportunity to express yourself creatively and design websites or design animations. Equally, there is an opportunity for you to be very logical and design very meticulous and efficient systems for churning through numbers or calculating big quantities of data. So the third reason is it's become increasingly high level. So when coding was first a thing, it was actually done on punch cards, and it took very specific kind of training and understanding to be able to effectively code something. Whereas these days you can pretty much write code in something that is very similar to plain English. So the abstraction away from low level bits of ones and zeros, you don't have to worry about that anymore. Whereas maybe when computers were first a thing, you had to work specifically with kind of binary data. Whereas these days you can say something like, fetch me this, do that, and it will just do it. Programming languages have pretty much got to the point now where you can pretty much train anyone to be able to do certain tasks, because there's not much low-level knowledge required in order to produce a working program or a working application. And the fourth reason is coding is highly sought after in industry. It's one of those skills that when you know it, it allows you to almost instantaneously get a job. There are very few skills out there that are in such demand as programming or coding. So if you're a student, say in high school, and your one and only concern is, how do I get a career that gives me a stable income and get a job that is stable and so on, then coding or something that involves coding is probably one of the most guaranteed ways of, supporting yourself and adding stability and getting something that is going to be reasonably high paid and potentially very high paid in the future. So next, I'm going to talk about a term that you've quite possibly heard, but you might not know what it is, and that is an algorithm. So in simple terms, an algorithm is just a set of instructions. Think of it like a recipe for a meal or a dish. So in a typical recipe, it might be something like peel the potatoes, cut the potatoes up into small cubes, put the small cubes of potatoes into a pan, fill the pan with water, boil the water, and so on, and until you keep following these steps and eventually you get the final result. So an algorithm is very similar, but it's not specific to food. Instead, you are instructing the computer to do something that computers are capable of doing. So some of the things that computers can do very well is add things together, or subtract, or multiply, divide, and many other operations as well. So a more high-level example of something that computers are capable of is comparing words or characters or sentences and seeing if they're the same or how different they are. Obviously, this is useful for things such as password matching. So when an app or a website asks you to enter their password, then it compares that password with what they have stored in the back-end side of things, like on a database. And if the two of them are correct, then it'll allow you into the particular website or app. So now that you know what an algorithm is, how does that relate to programming or coding in general? So once you have an algorithm, which you could have written in, say, plain English, or what a lot of people do is they write it in something called pseudocode, which is like sort of English, but it's sort of like in the form that a computer can understand. So what you need to do is once you have the pseudocode, which is a representation of an algorithm, and you can write that on paper or whatever it may be, you need to then write it in a way or convert it into a form that the computer can understand. And this is done by converting it into a very specific programming language. So a programming language is sort of similar to a spoken language in that when you compare, say, English to Spanish or French, they can all do pretty much the same thing, but there's just a different way of writing or speaking or saying those things that has the same meaning. So for example, in every language there's a way of introducing yourself, but that way is different between each language. So there might be a different sentence structure or a different grammar or different vocabulary and many other things. And when you combine all these things together, it creates a language. And it's exactly the same with a programming language as well. So with a programming language, you might need to say, I want to add this number and this number together, but you have to be able to speak the right words or use the right structure in order to be able to convey that message. So for example, in the programming language Python, if you wanted to create two numbers and then add them together, it would look like this. But in the programming language Java, if you wanted to do the same thing, it would look like this. So the end result is the same in that you're asking the computer to do the same operations, and by the time it gets down into the CPU, it's kind of executing the same pathways. But because the programming language is like an abstraction, it allows you to do very complicated things in simple terms. You need to be able to speak the right kind of words or the right kind of sentence structure. In this case, we're talking about syntax in order to be able to do the thing that you want to do. So the last part of this is the future of programming. So if you are any bit kind of interested in technology and programming, you might have even heard of something like ChatGPT. You can ask it questions and the chatbot will come back with answers. But what some people don't realize is you can actually ask it to code to some extent as well. And it's actually quite competent and quite efficient at writing certain pieces of code. The only thing is, at least at this stage, you need to be able to understand the code that it's written, because there is a slight chance it doesn't do exactly what you wanted it to do. So there may come a point in the future where there is no need to code because the AIs and the chatbots and everything else will be able to do it for you. But I think we're quite far away from that at the moment. And learning to code is still a very significant skill and one that will last for many years to come. What these AI systems are very good at, and one example is something called GitHub Copilot, which kind of uses the same types of systems as ChatGPT, but specific to a coding environment. You can roughly outline what kind of block of code you want to achieve, and ChatGPT or GitHub Copilot will be able to do that for you. But you still need to have the skills and the knowledge to know what block of code you actually need. So with ChatGPT or GitHub Copilot, what it really is there for is to aid you in your programming. You can't actually ask it to write you a full website, set it up, host it somewhere, and design it with very specific requirements and, design it in such a way that is very specific to your needs and so on. It's very good at doing stuff that other people have done before, but it's not so good at doing things that is very niche or very experimental. So the other thing about programming is there's such a wide range of applications that you can code for. So for example, web applications, you can code in a specific way, or if you want to learn how to write mobile apps such as iOS or Android, there's a different language or a different way of doing that. Again, these skills are all related, but there's just slightly different programming language or slightly different systems to be able to do those things. But equally, if you wanted to learn how to create video games, there's a specific way of doing that. And same thing for like AR or VR. All these things in some way relate back to programming languages. So learning the skill to code is so worthwhile. And if you kind of get overwhelmed by, oh, do I need to know so many different programming languages in order to learn how to code? The answer is no, because once you know how to code in one language, it's so much easier to learn another. A lot more easy than it is to say if you learn English and then you want to go and learn French. Because it's so vastly different, you have to learn all these things from scratch. Whereas in a programming language, you need to know how these things work once, and then it's just a matter of learning the specifics of a programming language that allows you to do those things. So that pretty much concludes the summary of coding, but if I haven't sold it to you already, feel free to reach out with any questions or whatever. But what I might do going forward is create another video, which is effectively going to be like an introduction to coding in general, like a practical introduction, which might go into a specific programming language, depending on what I think might be a good stepping stone or a good way to start. But in terms of this video, that pretty much wraps things up. So I will see you in the next one.